Okay, so now we're ready to do some numerical calculations. And notice that down here at the bottom, I've clicked on here. So this one here. So we're going to go to the lab portion. And now what I'm going to do is instead of getting out the light bulb, I'm going to get out a resistor. All right, if I click on the resistor, notice that it says 10 ohms down here. So the resistance of the resistor is going to be 10 ohms. Okay, then I'm also going to get out a battery. So going over here again. Take out my battery. If I click on the battery, it says 9 volts. Now I could change the voltage, I could change the resistance if I wanted to. You can do it if you want to. It's going to change the outcome of the experiment though if you do that. So we're going to say that the voltage is going to be equal to 9 volts. So let's go ahead and connect this up. So I need to get out a wire. And we're going to connect the wire to the battery. And then we need to go from the battery down here. Actually, there's a reason for this, so I'm going to do it this way. You don't have to. As a matter of fact, you don't even have to have this wire here. So you can connect this directly to the battery if you wanted to. But I just want to expand it a little bit. Alright, so you can see that it's got an electrical current in it because you can see the electrons moving around and around. Now we want to calculate what should the electric current be, and then we want to measure it and verify it. So let's first do the calculations. We're trying to find the electric current, so that's going to be the question mark. We're going to use this formula to calculate what the electric current ought to be. So we're going to say that the voltage is going to be 9 and that the resistance is going to be 10, and then we're looking for what is the current going to be. So we're going to divide this. So 9 divided by 10 is going to be 0.9. So that the current is going to be equal to 0.9, and then the official metric unit for current is the amp. So that's what we're expecting to happen, but now we want to actually measure it. So first, let's measure the voltage in the system. So a device that measures voltage is going to be the voltmeter. So if we grab this and we pull it out, now we want to measure the let's first measure the voltage of the battery. So if I take this probe and I put it over here, nothing happens. Okay, that's because it's not a completed circuit yet. So I need to take this probe and put it over here and put it in there. There it is. All right, so 9 volts. The battery is producing 9 volts of voltage. Okay, now let's find out how much voltage is across the resistor. So if we put our probes across it, it's going to be 9 volts again. So the voltage that is being provided by the battery is being used by the resistor. You also notice this has a negative sign. If you want to get rid of the negative sign, just reverse the probes. So we'll put that one over there and put that one over there, and now it changes back to a 9. So that's all that a negative sign is telling you, is your probes are reversed. Notice you did not open the circuit. So whenever you measure the voltage of a circuit, don't open it. You put the probes across whatever you want to measure. All right, now we want to measure the current. So to measure the current, we're going to get a current meter out. So that's going to be this one here. Now, let's do it incorrectly and see what happens. So that if I was to take out some wires and take the two wires and attach them to the battery the way that we did with the voltmeter, let's see what happens. Oh, that's not very good. All right, so we just blew up our ammeter. Actually, what would happen is there's a fuse in the ammeter that would pop, and then you would have to replace it. So this is not good. So let me open that circuit back up. Open this one up. This is a real pain to have to do this. All right, so I'm going to get rid of all of this. Now, this time, okay, so here's my original circuit. In order to measure current, you have to open the circuit. With the voltage, you did not open the circuit, but with the ammeter, you do. So all I need to do is open the circuit and then insert the ammeter. All right, and so if you read what it says there, it says 0.9 amps. So we have just verified Ohm's law, that V is equal to IR. Okay, we're going to take a break, and when we come back, we're going to take two resistors and we're going to put them together, first in series and then in parallel. And we want to see what's the difference in the currents and the voltages in the circuit.